Good morning to each and everyone. For today's video, we will be discussing about alkanes. But before that, let me introduce myself. My name is Joanne Lozada, your presenter for today's discussion. Did you know that the bristlecone pine is the oldest living organism on Earth? The waxy coating on its needles contains a mixture of organic compounds called alkanes. There are more than 40 million known organic compounds. Each one of these compounds has its own physical properties such as melting point and boiling point, and each has its own chemical reactivity. Chemists have learned through years of experience that organic compounds can be classified into families according to their structural features and that the members of a given family often have similar chemical reactivity. Instead of 40 million compounds with random reactivity, there are a few dozen families of organic compounds whose chemistry is reasonably predictable. Next, let's discuss about the characteristics of alkanes. Alkanes are the family of saturated hydrocarbons, that is, molecules containing carbon and hydrogen connected by a single bond only. Alkane is an aliphatic hydrocarbons which do not contain benzene. Alkanes are sometimes referred to as paraffins, a word derived from the Latin parum affinus means little or slight affinity. The major sources of alkanes are the world's natural gas and petroleum deposits. The general molecular formula of alkane for straight and branch chain alkanes is C sub n H sub 2n plus 2, where n is the number of carbon atoms in the molecules. The table below shows the first 10 alkanes. In the first column, we have the IUPAC name. We have the methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. In the second column, we have the number of carbons. Third column, we have Greek prefix. In the fourth column, we have the molecular formula. And in the last column, we have the condensed formula. Straight chain alkanes are named according to the number of carbon atoms they contain, with the exception of the first four compounds, which is we found in first column, methane, ethane, propane, and butane, whose names have historical origins. The alkanes are named based on the Greek numbers. According to the number of carbons, the suffix ane is added at the end of each name to identify the molecule as an alkane. So now let's proceed to the rules for naming alkanes. IUPAC, IUAPC. What does IUPAC means or what does IUPAC stands for? Unsa man ang IUPAC? So, according to my research, IUPAC is International Union of Pure and Applied Chemistry. So, let's proceed to the steps in naming the alkanes. Step 1. Find the parent hydrocarbon. Find the longest continuous carbon chain in the molecule and use the name of that chain as the parent name. If two chains of equal length are present, choose the one with the larger number of branch points as the parent. Step 2. Number the atoms in the main chain. Locate each alkyl branch and assign it a number according to which carbon atom is attached to. The name of the alkyl branch is followed by YL to indicate the number of carbon atom in a branch. Beginning at the end, near the first branch point, number each carbon. So, kailangan mo numberan. Number each carbon atom in the parent chain. Step 3. Identify and number the substituent. So, you need to identify na in step 3. Assign a number called a locant to each substituent to specify its points of attachment to the parent chain. If there are two substituents on the same carbon, assign them both the same number. There must always be as many numbers in the name as there are substituents. Always include a position number for each substituent, regardless of redundancies. Step 4. Write the name as a single word. To give the complete name, enumerate the substituents first, followed by the name of the parent chain. Note that you need to separate word and number with a dash. Second, separate numbers with a comma. And lastly, words must be interconnected, so no spacing, no spacing. If two or more different side chains are present, cite them in alphabetical order. If two or more identical side chains are present, use the appropriate multiplier prefixes like di, tri, tetra, and so forth. Do not use these prefixes for alphabetizing. So, dili nato mahimong basihan ang di, tri, tetra para i-arrange siya in alphabetical in naming. So, walay labot, again, walay labot ang prefixes sa pag-arrange alphabetical sa naming. Next. So summary, we have the prefix, parent, local, suffix. A chemical name typically has 4 parts in the IUPAC system of nomenclature. So again, we have prefix, parent, locant, and suffix. A prefix specifies the location and identity of various substituent groups in the molecule, while the parent selects a main part of the molecule and tells how many carbons atoms are in that part. The locant gives the location of the primary functional group, while the suffix identifies the primary functional group. So, we need to remember the formula na prefix, parent, locant, suffix. So, more na siya in terms in naming the compounds. Next, reactions of alkanes. So the result is that alkanes have very little reactivity and only undergo 3 major types of reactions, including the following. So we have the combustion reactions, halogenation reactions, and the cracking. So next, we have uses and function of alkanes. So, while I'm doing my research, there are a lot of uses and functions of alkanes, especially in everyday life. So, daghan kaayo gamit ang alkanes sa panahon karon. Alkanes are important raw materials of the chemical industry and the principal constituent of gasoline and lubricating oils. Natural gas mainly contains methane and ethane and is used for heating and cooking purposes and for power utilities. So, ug wala diining alkanes, wala ato ang cooking purposes kay dako di kayo ni og importansya ang alkane sa atong pag-cook. So, these are the list of uses and function of alkanes. We have the heating, fuel cells, we have the motor fuel used as compressed natural gas. Okay, next we have the examples of alkanes showing the formula and structure. So we have here the methane and ethane for the first column. Second column, we have the molecular formula. And the third column, we have the structure of methane and ethane. So, in molecular formula, we have CH4. So, we only have we have only 1 carbon in methane. So, mo na siyang nasa tunga. Then, hydrogen, mo ang kanang naa sa upat. So, makita na to, no? Based sa molecular formula, makita na to ug unsa maporma ang iyahang structure. So what are the uses of methane? So there are a lot uses of methane, but I only put 1. So uses of methane, it is used in automobiles, ovens, and water heater as fuel. Imagine, fuel, pwede pala siyang gamitin. 'Di ba yung methane? Actually, class, yung methane talaga is, ito yung kadalasang ginagamit natin. Ito yung laging ginagamit natin in everyday life. Next, ethane. Petrochemical feedstock for ethylene production, and it is used also for power generation. Next example, we have octane, nonane, and decane. So we have for octane, we have C sub 8 H18. So we can see in the structure. So, diba, the chain is getting longer na jud. The chain is getting longer. We have the nonane and the decane. So, uses of octane. Use of octane is here. Okay, let me read. Fuels with high octane numbers are used in high-performance gasoline engines. So, usually, magamit ang kanisya sa cars, engines man, gasoline engines. Nonane, used as a heating, tractor, and jet fuel. Nonane class is also used as a solvent, distillation, chaser, fuel additive, and a component in biodegradable detergents. So, next, decane. It is used as a solvent in organic synthesis and in the rubber and paper industries. No? Very useful kaayo ang alkanes in our daily life. So next, I have here the examples of branch chain alkanes. So this structure here, so let me use the pen. So this structure here, this one, ang name nito is 3-methylhexane. So, bakit naging 3-methylhexane? So, first, you start numbering the carbon where the nearest substituent occurs. So, yung CH3 is mas madali siyang makikita pag nagsa-start tayo dito sa right. So, ito, number 1, nilagyan ko ng 1. So, CH3, ito, let me use the pen. Ito yung number 1 dito. Dito ako magsa-start kasi mas malapit siya dito sa CH3. Mas malapit ito kasi pag dito tayo nagsa-start ng number 1, malayo siya. So, dapat you start numbering the carbon where the nearest substituents occur. So, 1, 2, 3. So, nandito sa 3 si methyl. So, 3-methylhexane. Ano tong hexane? Yung hexane, guys, ito siya. 1, ito 1, 2, 3. Yung naka-pink, yan lahat. So, hexane yan. So, 3-methylhexane. Kasi 6 ang carbon. 3-methylhexane. So, always remember, huwag kayong mag-leave ng space. So, wag mag-leave ng space. So, dapat one word. Interconnected. Ika nga, diba yung sinabi ko kanina. So, next, we have 3-ethyl, 4,7-dimethyl, 9-tos. So, ito siya. So, dito ka ako nag-start ng 1. Dito, 1, 2, 3. So, ito yung sinabi ko kanina, guys. 3-ethyl, so 3-ethyl and 4,7-dimethyl. Ma'am, nga naman nga, bakit nga yung dimethyl, di ba, bakit hindi yon ang nauna? Again, class, dimethyl, hindi, yung di kasi dyan, yan yung prefixes. So, hindi yan kasali. Yun yung sinabi ko na hindi yan kasali sa pag-a-alphabetize. So, 3-ethyl, di ba, mas nauuna yung E sa ethyl kaysa sa M sa methyl. So, again, yung di, hindi yan kasali. So, nagiging 3-ethyl, 4,7-dimethyl, 9 siya. So, di ko makita dito. So, nonane. Next. So, 3-ethyl, 4,7-dimethyl, nonane. So, next. Okay, let me show you this table 2.3. So, maybe a lot of you are asking na bakit yung methane, yung A and E ng methane nagiging methyl na lang, naging na-change ng YL. Alkyl group is a partial structure after the removal of one hydrogen from an alkane. So, as you can see on the table, we have CH4, ito yung alkane. So, yung name niya is methane. So, nabawasan ng hydrogen. Removal of one hydrogen from an alkane. So, yung CH4 nagiging CH3 na lang. CH3 guys is methyl. So, kaya yung ANE na change ng YL. So, removal of a hydrogen atom from the N carbon of any N alkane gives the series of N alkyl groups. So, again guys ha, alkyl group, ito yung nasabi sa step 2. Alkyl group is a partial structure after the removal of one hydrogen from an alkene. Next, example branch chain alkane. So, we have here 3-ethyl 2-methylhexane. So, bakit nagiging hexane? Again, yung count ng carbon is 6. 1, 2, 3, 4, 5, 6. So, ito guys, mauuna talaga ang E kaysa kay M, of course, alphabetical. So, 3-ethyl 2-methylhexane. So, ganyan lang siya guys, yung pag-name. Next example. We have here 4-ethyl 2,4-dimethylhexane. Guys, you need to write kung saan nag-o-occur, kung saan lumalabas yung methyl ha. So, we have here yung blue, ito, nilagyan ko ng circle. So, we have that. Dalawa yan. So, nag-occur siya sa 2 and number 4. Kaya siya dito 2,4-dimethyl. Ito siya 2,4-dimethylhexane. 6. So, sana may naintindihan kayo sa aking explanation. Hindi ko talaga kaya na ma-English lahat kasi of course, kailangan itong i-explain ng todo-todo. So, kaya tinagalog ko na lang. So, I hope you've learned something in my discussion. May nakuha kayo. And you've learned something from it. And alam ko marami ang importansya ng alkanes. So, that's it for today's discussion. Thank you very much for listening. Have a bright day and keep winning. And sana may natutunan kayo. Maraming salamat. Thank you everyone.